Alright, sorry about that. Here we go. The computer cut out. So the people just promised they're going to buy me an Apple computer. Okay, but anyway. Alright, so let's go with it. It will simply be 12,000 over 0.88 to the exponent. So the initial value of the computers was, is that correct? 22,738, comma 82 cents. Okay. Let's carry on with our lives. Yes, Dr. Van Squirrel. Did you get the sum right, my girl?
No.
Oh no, I put the sum in. Alright, let's see. What you should have written. Okay. Dr. Van, so you wanted to change your career path now. You don't want to become a maths teacher anymore.
Sir, I never wanted to.
Why you say that you can't? Okay. So we told that Dr. Van, so you don't have to be a medical doctor. You can maybe be a doctor in whatever field you want to do.
Okay, sir.
Alright, so we are told sets up a sinking fund to cover the cost of replacing her practice's medical equipment in 4 years' time. She makes the same annual payment into the fund, offering 10% per annum compounded annually. The first payment is made at the end of the first year, and the last payment is made at the end of the 4th year. What must her annual payment be in order to cover the replacement cost anticipated to be 1.2 million at the time? Okay. Sorry? Yes. What's wrong? Right, listen. Okay, settle down. So let's set up a timeline to see what they mean. Okay. So at the end of the 4-year period, at the end of this period, T4, she must end off with 1.2 million, 1,200,000. Okay. So again, she makes the same annual payment into the sinking fund of 10% per annum compounded annually. So the interest is 10% compounded annually, so it's 1/1. The first payment is made at the end of the first year. So T0, nothing is made. Not so. T1, she makes a deposit of X. Okay. Then she makes another payment at T2 of how much? She makes the same annual payment. So what would the next payment be? X, yes. And what would the payment at T3 be? X. And the last payment is made at the end of the 4th year, which is at this point. And how much is she paying here? X. Can you see that, people? So if you take that into account, what must the annual payment be? So in other words, we must calculate the value for X here, not so. Make this a bit smaller. So in other words, we must calculate the value of X. Okay. So what I'm going to do is, what formula do we use here? Compound formula. A is equal to P into 1 plus I to the n. Alright. So we go from there to there. What's going to happen? Okay, we could have do it one of two ways. I'm going to take it till the end. Okay. So it's X into 1 plus I, which is 10. So it's 0, 1. So it's X into 1 plus 0.1 to the exponent. How many years is that going to be for? Huh? That's 1, 2, 3 years. Can you see that? Plus, we consider that to the end. So it's going to be x into 1 plus 0.1 to the exponent 2 years. Plus, consider that to the end. So it's x into 1 plus 0.1 to the exponent. How many years that for? 1. Plus, that x at each point will just be x. How much must she end off with? 1,200,000. Can you see that, people? So what do we notice here? What can be taken out in pursuit of calculating x? You can take out x as a common factor. Can you see that, people? So take out x. What are we left with? What is 1 plus 0.1? 1.1 to the power 3 plus 1.1 to the power 2 plus 1.1 plus 1 equals 1,200,000. Can you all see? So how do I get x on its own? You divide both sides by the story here. Not so. Both sides will be divided by just this. I didn't highlight both, but we're going to divide both sides by that. Why does this happen? Okay. So, let's put that in the calculator. It's 1.2 million. Check, yes, that's correct. Over 1.1 cubed plus 1.1 squared plus 1.1 plus 1. That gives me an answer of 258,000. 258,564, comma 96. Who got that sum right? You going to become a doctor?
Me.
Yes.
All of mine is
Your hand is up for what?
I said all of mine is
Okay. But your maths mark will get you there, maybe you say.
maybe so.
Maybe, baby. Right. People, any issues here? No? Right, now we're going to go to the fun part of the paper. That doesn't sound very convincing. Graphs. Okay. So here we are told that given f of x is equal to 3 over x minus 2 minus 1. People, what type of graph is f of x? What type of graph is f of x? It's a hyperbola graph. Okay. Then and g of x equal to x squared minus 4x. What type of graph is that? Parabola. 5.1 says, write down the equation of the equations, which means to say there is 2. If this was in a bracket here, equation or equations, that means to say it could be 1 or it could be 2. Not so? Since it says equations, it's going to be 2. Okay. Write down the equations of the asymptotes of f. So what's the equation? X is equal to 2 and y is equal to negative 1. Okay. Then it says determine the x and y intercepts of f. So how do we work out the x-intercept? Let y equal to 0. So 0 is equal to 3 over x minus 2 minus 1. solve for x, we take it over the equal sign, we cross multiply, so x works out to be 5. On the other hand, we got the y-intercept. What do you do for y-intercept? X equal to 0, so you say f of 0 is equal to 3 over 0 minus 2 minus 1, so it's going to give you minus 5 over 2 or negative 2.5. Not so? So we have x is equal to 5 and y is equal to negative 2.5. You all okay with that? Right? You guys are yawning already. It's been a long day of selling a fat cook. No? If you had too many fat cook, now you're tired. Am I right? Yes, Anna? Right, 5.3 we are told. Write down the coordinates of the turning point of G. Coordinates of the turning point of G. How do you work out turning point? Minus b over 2a. That's your x value. So it's going to be minus 4 over 2a, which gives you 2. Not so. So what do I do with that? I sub that into g. So g of 2 is 2 squared 4 minus 4 times 2 is 8 is negative 4. Is that correct? So what is the turning point of g? 2 and negative 4. Okay, I'm going to take this off so that I can have all the information in sight when I draw the graph. You guys start university, in your first year they have what's the name, literacy, computer literacy. And they let you do all of these things, cut and paste it, all of these things, no? Not for maths, it's one of your subjects. Computers. Computer literacy. Compulsory in your first year. There's 2 subjects compulsory, if you're not doing languages, no? You must do English for your major. So it's English for commerce or English for whatever. And then in your first semester, which is 6 months, and then you write letters and all of those things. And then in the second semester you do computer literacy. Yeah. But it's easy. Don't believe it's so easy. No? He says here determine the x and y intercept of G. X and y intercept of G. So for the x-intercept, what do we do for x-intercept? We let y equal to 0. Okay. So we got 0 is equal to x squared minus 4x. So we take out x as a common factor. Now we're left with x minus 4 is equal to 0. So therefore, x is equal to 0 or x is equal to 4. There's 2 values here, x is equal to 0 or 4. Then we work out our y-intercept. What do you do for y-intercept? Let x equal to 0. Yes? Sorry?
When we work out y is equal to 0, so one of the answers was x is equal to 0. So we're just taking in y, so x is going to give us y.
Absolutely. Yeah. And so she's saying I could pick up from here already. If x is 0, your y is going to be 0 anyway. Nice, but not everybody is as sharp as you, Michael. Aaron, yes. So yes, so y is equal to 0. But you are absolutely correct. Okay. Right. Now the question says, throw in the yes. You didn't come check your paper after it was marked. You to be blamed and I'm to be blamed.
You still change it.
If I change it now, what's the difference? Prouder.
So if you change your mark, it doesn't change your report. No.
Do you think you got a magical report like? If I change it now, you can change when you get home? No. if I give you that 1 mark and it goes up by 0.5% or a whatever, it's not going to make any difference now.
What if the half of percent was what we need to get a distinction?
Distinction.
It will not be to a.
But it's not going to, if you get a distinction now, then what's the difference?
Again,
Yeah, but listen, if you get 79%, that is good enough for them, yes?
So can you add my 2 marks to like my big one?
Yes! It's going to make a difference.
Right now.
What for you? Alright. Alright. People draw a graphic with me. Do you see now? I forgot what I must do. Right, let's go. So we're drawing the graph. So what is your x-intercepts? 0 and? Was it 4? Okay, it's a smiling parabola. We're frowning parabola. Smiling. Your turning point is 2 and minus 4. So 2 and minus 4. So there's your turning point. Yes? That's your graph of g of x, no? That's it. No? Graph of g. Then your f graph. Let's see what they tell us here. We got an asymptote at 2 and at minus 1. Not so? 2 and minus 1. Okay? Then it has an x-intercept at 5 and at negative 2.5. 5. The one transition comes through like that, and that 4 is here, 1, so negative 2.5 is approximately there. So there's that graph of f. It might be that this graph is going to cut that graph there. Okay. But if it doesn't, or if it doesn't make a difference to us at this point, okay? So there's your 5 marks for the graph. Why are you laughing at? You're smiling. Make me worry when people are smiling and laughing. Huh? Oh, me too. Right. So 5.6, it says determine the value of k for which g of x minus k will have no real roots. People, k is what? K is a y value. Not so. So this graph is a shift on this graph. So if we're looking at g of x currently, how many roots does g of x have? Currently, how many roots are there? There are? 2 roots, yes. Why is there 2 roots? Where's the 2 roots? Is that 0 and at 4. The 2 roots are at 0 and 4. What are roots? X intercepts, so 0 values. So the one is going through like that. And that, okay. So now looking at k, so I'm taking this here into account. Okay. So they want to know determine the value of k for which the values of g of x minus k will have no real roots. So currently there's 2 real roots. So if the graph moves up, so if I say plus k, okay, if I move this graph up, how many units do I have to move up for this graph to have 1 root? For it to bounce off the x-intercept. How many units must this graph move up by? Huh? 4. 4 units. So anything more than 4, how many roots will you have on that graph? You move it up more than 4. Huh? 0. 0 roots. Which means you say it's not going to cut your x-axis. So taking that into account, if I got g of x plus k, I know it's minus k. then that means to say, for k is greater than 4, then you will have no real roots. You all agree with that? As long as k is greater than 4, there's no real roots. However, there's a negative there. So in other words, it's where g of x minus k is the case. Okay? So because I considered it to be positive here. And I derived k has to be greater than 4. But it's actually negative there. So it's negative k must be greater than 4. So therefore, k must be less than minus 4. So any value less than minus 4 will result in the graph of g of x having no real roots. We can test it. Choose any value less than negative 4. Negative 5. Right, I see you guys getting this. So g of x, so g of x minus 5. So in other words, it's g of x plus 5. If I move this graph 5 units up, would it have no real roots? Make so? Yes. It will have no real roots. Why? Because it won't cut the x-axis. Does it make sense? Okay. If it doesn't, it's fine. There's many more of this still to come. Sometime or other you must get it, otherwise you're going to get it wrong in your final exam. Okay, I think we'll stop here today. You want to carry on? It is now 4:45. Yeah, you see, we got 10 minutes, but it's going to take more than 10 minutes to answer this question. Unless you can carry on until 4:15. Okay. People, that's where we're at. So next week, there's no class next week because of the sports. The following week, we'll wrap up at the 1. Okay. People, enjoy the rest of your day and your weekend. Good afternoon, class. Please collect the files again.